Hello everyone. I really hope that you gained some energy for the last presentation for today. So just before we start, let me introduce myself. Well, my name is Pavel Apalkov. I work in IT sphere at least 8 years, and during this time I had a great chance to work on different projects in telecommunication and banking spheres. And in 2024 I joined inDrive, and right now I mainly develop our dev platform product. In previous presentations, Ladislav and Daniil showed how widely inDrive projects are presented. Just let me remind you these numbers. So 25% of world coverage, 8 million writes per day, more than 500 microservices that are running in 15 AWS clusters. Everything is growing. Amount of services is growing. Amount of business features is growing. And all of this creates a very good challenge for us, for platform, to make a stable and safe deployment process. And this is the topic that we are going to talk about today. How to make your deploys stable and safe for your business. But today, I don't want to tell you about the tools that we are using right now. Samurai has no destination, just a journey. So I would like to tell you about the journey that we made to come up to our current stage. inDrive was founded at 2013. But I will start my story in 2024, because that was the period that brought us here, that showed some things that we had to solve. But in order to make our speech more interesting, I would like to go through some metrics that we're going to track today. First of all, it's change failure rate. But with a small mark that today we will talk about the changes that just break the production. Because that period, even this was a huge problem. That new services versions just couldn't finish the rollout because of some errors. And since we are on Developer Experience Meetup, it will be interesting to see how our changes would affect Developer Experience Index. Ladislav has already told you about it, and what is it? And if before that Daniil showed some numbers for platform overall, I will tell only about DevEx index of deployment process, because our changes affect on it. And let me show you some initial values that we had for the beginning of 2024. Change failure rate was about 7.8%, which is pretty far from good. But the DevEx index for that time was pretty high. It was 3.95. And you will learn why it was that time. So, when all the numbers are set, let's start. Daniil already told you about our development platform. It was developed as a very simple tool for developers, for different purposes, but also for purpose of deploys. I already told you that we have a lot of AWS regions that we had to roll out to. And Dev Platform allowed all the developers do that in a single pipeline. When service was production ready, developer just click one button and the service starts its rollout. But the question is, what is production ready service? For some people, they say that it's unit tests. Some people say that it's API tests or documentation. And including the growth of number of developers in inDrive, number of opinions was growing also. But what did it lead to? It led to our CFI metrics started growing. And at the period of high season, there was a lot of incidents that we had to solve immediately. Just imagine this number, 15% of change failure rate means that every 6th rollout just fails. And so, the interesting question is, how to drop this metric immediately. Yeah? And one obvious answer is when rollouts breaks production, you should stop rollouts. Yeah, why not? No rollouts, no errors. But to be serious, we went to the area that we call code red. Yeah, code red is a number of limitations for deploys. Yeah, first of all, our deployment policy became pretty strict. Yeah, if before that developer could roll out the change in all regions at the same time, yeah, we started making rollouts just one by one. Secondly, clusters order was fixed, because there are some regions that has pretty low load. Yeah, so other regions had more impact for our business. Yeah, so that's why we should start our rollout from something safe. Then all clusters must keep the same version before deploy, yeah, and after deploy. Because at that time, we could see that developers wanted to test the feature on production in a specific region. And it's not very safe. Yeah. Also, that time developers had a freedom of deploys from different feature branches. Yeah, and that was limited too. And the final limitation, which was more important than others, then only engineering managers had deploy access. Okay, let's see what happened with our change failure rate metric. Of course, it dropped, obviously, yeah, so it worked. But at the same time, well, our pretty high DevEx index, yeah, dropped too. First of all, because that freedom that our engineers had, yeah, was taken from them. But the thing is, when deploys are limited, the speed of feature development, yeah, and feature rollouts decreased too, and that is not very good. And we had to solve this problem just one by one. First of all, we realized that not all the services had the same impact on inDrive's business. Yeah, and that was the time when tiering module was introduced. What is it? First of all, tier is a service classification system. Yeah, in inDrive we have 4 tiers, yeah, 4-level system. What does it mean? It reflects the impact that each service, yeah, has on inDrive's business. The higher the tier, yeah, the more impact and the stricter the limitations that it had for deploys. And vice versa, yeah, the lower the tier, the lower impact, yeah, and the limitations were more relaxed. For now, in inDrive, we have about 130 undefined services with undefined tier. What does it mean? These are the services, yeah, that are used for development or for testing purposes, yeah, such as, well, QA tools, yeah, some system services, yeah, like, I don't know, MySQL containers, something like this. Something that we do not roll out in production. Then we have a bit more than 200 tier 1 services, 111 tier 2 services, 59 tier 3 services, and only 9 tier 4 services. Yeah, these are the services that impact inDrive business most. Yeah, and all the limitations that are most strict, yeah, there for them. What else? What else? Also, our development platform was evaluating too. And we developed a feature called quality gates. Teams could create quality gates for their services for their own. Yeah? If a team thinks that they have to run unit tests, yeah, or they run API tests, or they run something else, yeah, they could make a rule for that in our dev platform. Yeah, and the best idea of this feature that it can stop rollouts, that it can forbid rollout if something is wrong. And more than that, our Dev platform has command line interface, that allowed to integrate this process into CI. Okay. How did these features, the steering model and quality gates in Dev platform with some relaxed policies for deployment affected our metrics? Well, not very good generally. We can see that change failure rate started growing again, but the good point is that it keeps on a bit lower level than average previous year. Well, that's good, but not much. But anyway, if we come back to our DevEx index, we could see that it started growing again, and that's good. But the problem is that, at that moment, quality gates were set up by teams themselves. And well, it's absolutely true, then if you make rules yourself, you'll break them yourself. And we could see a lot of examples when teams bypassed these checks in order just to deploy the feature. Because there are some urgent situations, they just wanted to test something or something like this. And well, it means that it does not work. Okay. But what if we try to think about more areas that we want, where we want to control the quality? For example, documentation, observability, security, architecture, infrastructure, quality assurance, and any other areas that are connected with the deployment process and development process. And we would get our service maturity model. The basics of service maturity model that we are using nowadays. What goals we set up in front of this model? First of all, we want to set up the definition of production readiness, aligned with service steering, of course. Because as I told you before, not every service has the same limitations. Secondly, we wanted to improve our technical debt management. Because there are a lot of tasks connected to documentation or observability charts that teams often drop to backlog, and it keeps there just for, I don't know, for quarters, for years. Well, we have these examples, unfortunately. And finally, we wanted to reduce cognitive load on engineers and engineering managers, because if everyone tries to think about all these areas themselves, they can forget about something, or just it will make harder to develop their business features, because these platform features needed some more cognitive load. Well, it sounds very cool, but first service maturity model version was managed by some platform teams. We have different teams for backend practices. We have a separate observability team, or some people who own documentation process. And each of them tried to set up their own number of rules for this model. And of course, because it was just an MVP at first, this model was Excel-based. The best instrument ever, well, the first version of service maturity model had more than 100 rules. To read all of this is pretty hard, but what is more harder to understand what each rule means. We had some descriptions, we had some instructions, but not all of them were complete. And more than that, teams had to go through this model themselves and to make self-assessment. And well, which is hard too. And finally, this Excel-based approach is not connected with rollouts. And if it's not connected with rollouts, it means that it won't affect our metrics. Okay, let's make a small pause here, and go over all the insights that we have for now. First of all, tool must be user-friendly, not that functional. So Excel is not French, pretty hard, something, something from 2000s, something like this. Secondly, manual assessment has a high false positive risk. Yeah, because if, for example, if a team does not understand in general, what each check wants from them, they can just click that everything is good, and go. Then, a large and complex model increases cognitive load. We could see that engineers and managers had to read all this model, had to dive into it. Well, it's pretty hard. And finally, that it somehow needs to connect it with our deployment process in order to affect our metrics. And it's very good time to turn all these insights into actions that we're going to solve. First of all, let's talk about tooling. We went through different instruments, different open source instruments, different BI instruments, but finally we realized that our dev platform is the best place for that. Because each could make an interface for teams that could run their assessments, and each could have interface for managers who maintain the checks. And what was the result for that? The teams just had a new UI, but they wanted in the single place where they work. And when they had red numbers here, it was just push from themselves to fix it. It was not push from somebody else, and that's good. But the problem is its self-assessment is still here. So, and the number that we got even for that point, that we reached about 50% of service maturity model compliance by services. But what we know that it's self-assessment. But anyway, even at this point, we can say that we solved the first problem, because the tool became pretty comfortable. Let's try to solve the next one. If we say that manual assessment is risky, it means that each rule must be automated. And we started a very big stream of service maturity module automation. When we just automated about 25–30% of service maturity model, we can see that overall compliance increase reached 60%. And more than that, automation has a side effect. It does not solve the problem of high false positive risk. It also reduces cognitive load. Because when a check is automated, engineers do not have to dive into the meaning. They do not have to realize what check wants from them. They just see the error. They just see the instruction how to fix it. And more than that, some AI tools that we are also integrating in our processes helps them to do it faster. Okay. Right now it's time to see how it affected our metrics again. And the good point is we can see a small trend of change failure rate decrease. It's still not perfect, but it's a small trend for getting better. And if we come back to our DevEx index, we would see that it's increasing again, up to 3.87. It's still lower than initial values, but it's better. And finally, it's time to solve the last problem. The problem of connecting service maturity model with deploys. As I said before, we based service maturity model in Dev platform, and we based it on our quality gates. And quality gates can block rollouts. So that's why one by one we started making our service maturity module checks required for deploy. What can we see in this chart? Well, we can see some trends here. That's pretty interesting. First of all, we can see that increase of percentage of required checks is directly connected with increase of automation. Because, as I said before, all the checks must be automated. Yeah, and it's also pretty good point that we should make our service maturity model in the way that all the checks must be automated. Because if check is not automated, it means that it has high false positive risk. Okay, what else do we have? We can see this time gap between automation, and making check required. Why is good? First of all, it lets teams to plan fixing these gaps. Yeah, at the beginning of each quarter, we set a number of rules that will be required at the end of the quarter, and all the teams have an opportunity to plan this in their quarter capacity. Yeah, it means that it won't be a surprise for them when we make some more checks required for deploy, and it will not be a surprise for them. And it will not affect the speed of their business feature rollouts. And finally, what I want to mention here, that we can see that the speed of automation increase and the speed of required check increase is a bit faster than service maturity model progress increase overall. First of all, it's connected with that we started automation and we started making checks required with that checks that were pretty obvious, that most of the services and teams were already following. And we expect then automation came through the less popular checks, for example, connected with documentations, or something like this. We expect that this speed would be the same, that this model progress overall will increase too. Okay. And at this point, we can say that, well, we solved the last problem. Yeah, we're still in progress, but we already set up a process that we are running at. And right now, it's time to the final check of our metrics that we were looking through. Our change failure rate right now has a strong decrease trend. Right now it's less than 5%, and it's our target value. That's cool. And more than that, when we come up to development experience index, we can see that it increased even more than it was in the beginning. But on the other hand, it's a bit surprisingly, because more required checks means means less engineer satisfaction. But it's mostly connected with the way we introduce these changes, that all the teams have a time for adaptation. That's great. But let's make a small step back. During all the presentation, we talked about change failure rate with that red star. What is it? It is about the changes that are only breaking the production. But for now, we can see pretty interesting trend that our engineers started more rollbacks for even successfully deployed services. And this is a very good point for investigation that we're going to do right now. And I think that we're going to see pretty interesting results. Well, just for now, we think that it's connected with business metric drop, or the teams try to keep testing on production. But anyway, that's not good. And unfortunately, this is the point that service maturity module does not cover yet. But we hope that it will be. Okay. And so finally, what just I want to say, that service maturity model is not just a set of rules. It's our production-ready definition for services. With this tool, we can not only measure quality, but we can also work with tech debt. Because we can see that a lot of tasks that teams had in their backlog, they are solved. But what is the most important, that we saw that limitations do not always cause DevEx index drop. Yeah, because reducing cognitive load is a key factor of our work. Yeah, we always try to ask ourselves how to make engineers think less about limitations, think less about the requirements, and focus on their business features. Yeah, and this approach works, and we can see it here. So that's all for today.